Hello. In this lecture, I will talk to you about the topic aldol condensation. We will next session we will talk to you about Perkin and Claisen condensation. And in this lecture, I concentrated on different reactions of variety of aldol reactions, which comes under the topic chemistry of carbonyl compound of second semester MSc, Calicut University. Coming to aldol reaction, aldol addition or aldol condensation is an important class of carbon-carbon bond forming reaction. In this reaction, an addition of enolate or enol, to the carbonyl carbon of aldehyde or ketone, and which leads to a product beta hydroxyaldehyde or ketone, that is called aldol. For example, an acetaldehyde itself condensed self-condensed in presence of base, and it give an hydroxybutanol. This product is called aldol. So let's see the mechanism of the reaction. First, acetaldehyde in presence of base, it form an enolate. The enolate formation is due to the acidic nature of this alpha hydrogen. Why this alpha hydrogen is acidic? Because it is very next to the carbonyl. This carbonyl is an electron withdrawing group. This hydrogen will be acidic. So it form an enolate first. Then this enolate will be added to an aldehyde. So this is the enolate. This enolate is nucleophilic. This carbon is nucleophilic, and this enolate will be surrounded by aldehyde in the system. Then this enolate can act as a nucleophile. Other carbonyl on the acetaldehyde can act as an electrophile. So this carbon will be nucleophilically added to this electrophilic carbonyl. Then it form an alkoxide. Then this alkoxide protonated by water, and finally it form an aldol, that is called 3-hydroxybutanol by the regeneration of hydroxy group. So here hydroxy group is acting as that means it is acting as an catalyst. So important point in this aldol reaction is this is a carbon-carbon bond formation reaction, and the nucleophilic part is the enolate. This carbon is acting as a nucleophile, and electrophilic aldehyde, this carbon is acting as an electrophile, and CC bond formation occurs here. Occurs. And next point, the rate determining step. If you are using very low concentration, hydroxy concentration, base is very low, then this step is the enolate formation step is the rate determining step. And if you are using very high concentration of hydroxyl group, that is base, second step, the nucleophilic addition of enolate to the carbonyl is acting as an rate determining step. So if this same aldol reaction can also be occurred in case of ketone also. For example, acetone. If you are using acetone, first it form an enolate of acetone. Then second step is the carbon-carbon bond formation reaction. Enolate will be added to second molecule of acetone, and it form finally an aldol. That product is also called aldol. For example, in the case of acetone, you get for hydroxy 4-methyl pentane 2-on. And usually aldol reaction works well with small concentration of dilute bases. In the case of aldehyde, the best base is dilute sodium hydroxide. The case of acetone, that is ketone, barium dihydroxide is the best one. When you add more base, what happens is dehydration occurs, take place, and it gives a stable unsaturated conjugated carbonyl like this. For example, this is the aldol product from acetaldehyde. In the presence of high concentration of base, it gives a dehydrated product that is called crotonaldehyde. If you are using acetone, aldol, in presence of excess base, it gives a dehydrated product. That means it undergo a dehydration like this here, and it form, in the case of acetone, it gives mesityle oxide. This is the mesityle oxide. So what is the mechanism of dehydration? Final step. Actually, it undergo even CB elimination, that is conjugated base. CB means conjugate base elimination. Actually, in excess of base, it deprotonated this hydrogen. That is, this hydrogen is acidic because of this carbonyl and this hydroxy group. This will be acidic, and it form an enolate first. Enolization step, enolate it form. Then that enolate undergo an elimination step like this. That is, this pi bond will be restored, then this double bond break, then this hydroxy group will get eliminated. And this is the even CP mechanism. This is called even CP mechanism. And what are the conditions of elimination? If you have a very strong basic condition and very high temperature and long reaction time, this type of elimination step occurs. Next reaction, we already seen the base catalyzed reaction. Next one is acid catalyzed reaction. In presence of acid, it also under aldol reaction occurs, but only the difference is instead of enolate, it form enol. First, it protonates like the cyclopentanone. For example, in the case of cyclopentanone, protonate the carbonyl first, and it form an enol like this. And these enols are less nucleophilic. Then how does the reaction occurs? Because the carbonyl, next carbonyl become more electrophilic by protonation. So it enhances the reaction rate. So this reaction, condensation reaction, carbon-carbon bond formation occurs like this. And it forms an intermediate like this. Then it deprotonated to give final aldol product. And this aldol product can undergo elimination by even mechanism in presence of acids. In the case of acid catalyzed aldol reaction, to undergo even mechanism. And this is the final product. This hydroxy group on protonation, it give an hydrosonium compound. This is a good living group, and it form a carbocation. And this carbocation, it form an elimination reaction like this, and it deprotonated to give an conjugated carbonyl product. So in conclusion, base catalyzed aldol condensation give aldol product by even CP mechanism, and acid catalyzed aldol reaction may give aldol product usually with even elimination reaction. Next one, aldol reaction in the case of unsymmetrical ketones. For example, this one. Here you can see a methyl group here and a tertiary alkyl group here. And this tertiary alkyl group cannot be enolized, but this can be enolized. Another example, an unsymmetrical ketone is methyl group here and a phenyl group, aryl ketones. And here in both cases, only one carbon is having alpha enolizable hydrogen atom. So it can undergo self aldol condensation like this. So only one carbon can undergo enolization, and this enolate can be added to the next another molecule of second unenolized molecule of ketone, and it forms an aldol product like this. Similarly, this can also be formed like this. So next one, cross-condensation. The same unsymmetrical ketone can undergo cross-condensation like this. For example, this ketone, aryl ketone, can undergo, this contain an enolizable carbon atom, but this is the another molecule and this is not having enolizable carbon atom. So this can undergo aldol reaction in presence of base, and this one is not having alpha hydrogen and this is having alpha hydrogen. So this can form an enolized carbon atom, enolate, and this enolate can be added to this non-enolizable carbonyl and it form a product like this. So these are the examples where the cause aldol condensation occurs. For example, benzaldehyde and propanol, it form a product like this, and you can use a phenyl acetaldehyde. And this part is non-enolizable part, and this one is non-enolizable part. And in this reaction, you have to take care. A reactant with no alpha hydrogen should be placed with base, and reactant with alpha hydrogen should be added very slowly. Why you are adding this alpha hydrogen reactant with alpha hydrogen slowly is because otherwise it can undergo self-condensation. So in order to cross condensation to occur, cross condensation, you have to do this reaction like this. Okay, in summary, you can you have to, for successful cross condensation, for this kind of cross condensation to be occurred, what are the conditions? One partner only must be capable of ionization, and other partner must be incapable of ionization and more electrophilic, should be more electrophilic than ionizable partner. Otherwise, reaction should not occur. This is the most important thing. It should, other part should be more electrophilic than ionizable part. Okay, that's all for aldol condensation reaction. Thank you for listening.